All right, class. So today we're going to get through 10.4 and 10.5. I'm going to do, so basically we've done vertical, right? As you can see here, we've done amplitude, we've messed with vertical shift, we've messed with wavelength, and now we're going to mess with horizontal shift, okay? As you can see, we've got about 6 problems here, 4 in radians and then 2 in degree. So we'll do all of them. I'll probably do 3 of them with you, and I will have you do 3 of the 3 others, right? So, yeah, that's pretty much it. Then we're going to come over here. I'll probably just do 1 of these. I think you can do the rest, okay? So we're actually going to do 10.5 as well. As you can see, what we have here is we just have some graphs, and we're going to answer amplitude, vertical shift, and wavelength. I'm not going to do any horizontal shift here, and then we just come up with the 2 functions, okay? So that's our goal for today. Should be relatively quick. We'll see how this goes. All right, so let's get started. We'll do the very first one. So this one's in radians. So let's just kind of write down something real quick here. In the function, f of x equals a cosine, then in parentheses, b x minus, we'll do x minus, let's give this a c, why not? And then we'll say plus d. There we go, a, b, c, d. That's fine. Basically, we have a, that's our amplitude. We have our wavelength equals 2 pi divided by b, right? We have our vertical shift equaling d, and we're going to have our horizontal shift equaling c. Okay, so that's kind of where everything is happening here. Notice how it's minus. That minus means that it's the opposite. Let's just get started though. Okay, so first off, amplitude here, 4. Vertical shift, 3. That one's pretty easy. In fact, let's just go ahead and do our 3 up to 7 down to -1, right? So again, just a reminder, that's your vertical shift. Then you both add your amplitude and subtract your amplitude, right? Wavelength. Okay, let's do wavelength now. Well, wavelength equals equals 2 pi divided by your b, which is pi over 2. Actually, I'm going to take this and move it up here, just so we can, okay. Well, that's actually 2 pi times 2 over pi, right? Instead of dividing by a fraction, let's multiply by the reciprocal, and this gives us 4. So our wavelength is 4. And then a horizontal shift, again, is the opposite, so it's -1. So here's our horizontal shift, but remember, it's opposite. So our vertical axis, we've done our vertical axis, horizontal axis. Now, what it does is it shifts this entire graph. So instead of starting at 0, we are actually going to start at -1. We're going to start at our horizontal shift, okay? So we're going to start at our horizontal shift here. Then what we do is we go forward our wavelength. Forward our wavelength means from starting here, we're going to add our wavelength. Well, if it's at -1 and we're adding 4, that means that we must get all the way up to 3. Okay. How do we find the middle of -1 and 3? Well, that's actually pretty easy. What you can do is you can actually just you can do this 2 different ways. You can take your wavelength and divide it into quarters, which is super easy because in this case, our wavelength divided into quarters is just 1. So every one of them is just adding 1. So it goes -1, 0, 1, 2, 3. The graph is simple. It's a positive cosine. Starts at the maximum, goes to the middle, goes to the minimum, goes back to the middle, then back to the maximum. Done. Okay, so that's how we deal with our horizontal shift. Let's do one more. Let's do just right next to it, number 30. Here we go. Here's number 30. So we'll start again. We've got amplitude, vertical shift, wavelength. Ooh, okay, so let's do wavelength off to the side. Wavelength is 2 pi divided by, in this case, 2. Oh, okay, that's easy. That's just pi. Perfect. Horizontal shift is the opposite of what's inside, so it's actually a positive pi over 2. So our vertical axis starts at -2, goes up to, so we'll add 3 here, we'll get to 1, and we'll also subtract 3, and we'll get to -5. So that's our maximum and our minimum. We'll then now do our horizontal shift, which is right here, which is pi over 2. And what do we have to do? Well, again, we have to take pi over 2 and add pi. All right, well, we can go off to the side and do that. If I had pi over 2 and I added pi, in other words, instead of adding pi, that's 1, right? We're adding 1, but we got to do it in halves. So we're actually going to add 2 pi over 2. That gives us 3 pi over 2. So we're actually going to go all the way out to 3 pi over 2. Now this one, a little bit harder, but not that bad. Our wavelength is pi, so we're going to go up 1/4 every time. Another way to do this is you can add and divide by 2, right? If I add them and divide by 2, I find the middle. So either way, doesn't really matter. So if I add these two, I'm actually going to get 4 pi over 2 divided by 2. That's actually, if I divide by 2, that will actually equal just simply pi. So in the middle, I'm going to actually have pi. This should actually make sense because, like I said, if we wanted to, we could also do the pi divided by 4. You know, pi being the wavelength, divide by 4 to get it into the 4 spots. 1/2 plus 1/4 is 3/4, so that's 3 pi over 2, or sorry, 3 pi over 4. So we're gonna add this up, right? So we're gonna basically, this right here is 2 pi over 4, so this is 2/4, 3/4, 4/4, 5/4. So that's the one that we're missing. Done. Now we're gonna graph it. This is sine. Sine always starts in the middle, no matter if it's positive or negative. So here we go. It's going to now go, but it's a negative sign, so it actually goes to the bottom first, then back to the middle, then to the top, then back to the middle. And so to graph it, looks like we're getting this. Oh man, that last little bit bad. Try that again. There we go. We got ourselves a nice little sine wave with a horizontal shift of pi over 2. One more. So I want you to do these two, right? These are in radians. And then let's actually go down and do degrees. Exactly the same thing. Nothing changes. Okay. Let's do, let's see, let's do the second one simply because I actually forgot a parentheses there. There should be an extra parentheses right here, by the way. So let's do this one. All right, amplitude. -2. That's easy. Vertical shift, +4. Okay, well, let's just do that right now. 4 up to 6, down to 2. Excellent. Wavelength, well, we have 30. So in this case, it's 360 divided by 30, which is 12. There you go. So the wavelength is 12. Horizontal shift, -4, because it's this one, right? And it's the negative of that. Great. Okay, so that means horizontal shift. We're actually going to start at -4, and we're going to go forward 12. Well, -4 plus 12 is 8. So we're going to get all the way to 8. Also, well, if the wavelength is 12, let's split it up into 4 pieces. That's 3. So each quarter is 3 units long. So if I take -4 and add 3, that's -1. if I add 3 again, here, let's actually get these evenly spaced. I'm going to space these a little more evenly now. Let me do that again. So here, here, and here. Okay. Again, 3, right? So we're going with this idea of, hey, here's my wavelength. I'm going to divide it into quarters. I have 3. So each unit needs to be 3 long. Each quarter needs to be 3 long. So -4 plus 3 is -1, plus 3 is 2, plus 3 is 5, plus 3 is 8. So that's a nice little confirmation when we hit, we hit the 8, and I said 8. So that's a nice little confirmation that I'm actually doing this correctly. Let's do the graph though. Again, negative sign. So start in the middle. I don't like how my pen disappears. Go to the bottom, go back to the middle here, then go to the top, and then back to the middle. So what do? We go like this, there, right? Back to the middle, back to the top, and then back to the middle. And we're good to go. Nice. So do number 33 as well. Let's do one, let's go over this page. You've got 6 problems here. Let's just do a group of 2, okay? It's actually pretty simple. So what you want to do is you want to find one wavelength. So notice how here's F, okay? There's F. And what we have here is we're going to go one wavelength. Well, if it goes up, down, goes back, starts going back up, and then hits right here, that's one wavelength. So it starts here and gets to here. So what we're going to do is we're going to actually stop this here in a sense, okay? That's a single wavelength. This would be wavelength 2, if you kind of can see it. So hopefully this is somewhat helpful. So what is my amplitude? Well, actually, vertical shift might be easier. So with F, the vertical shift is 2. Now the amplitude goes from 2 all the way up to 5, so the amplitude must be 3. What's the wavelength? Well, the wavelength must be 1. So by the way, if the wavelength is 1, then B equals 2 pi over the wavelength, or 2 pi, okay? I'm going to prove that real quick, right? So we before said that the wavelength equals 2 pi over B. Well, just multiply both sides by B, and then we have BW equals 2 pi. So then divide both sides by W. So B equals 2 pi over W. So just take 2 pi, divide it by whatever your W is, and you'll get your B. The setup here, just so you remember, is going to be A, then your trig function. In this case, our trig function is clearly, well, let's think about it. Our trig function starts in the middle, goes up, down, and back to the middle. This is a sine function. Not only is it a sine function, it is a positive sine function. So if it's a positive sine function, we're going to do a sine of bx, right, plus our vertical shift. In other words, our d, if you remember that. Yeah. So in this case, relatively simple. I'm going to erase that real quick. A is 3. This is a positive sine function. Then B, put the variable in there, so x, and then add your vertical shift, and you're good. Let's do another one. So let's do the one in red. So again, we're going to start here. So here's our start. It looks like it goes up to its maximum, then back down to its minimum, and starts over. So here's our wavelength. So wavelength looks like it's 2, right? All right. Amplitude. Well, where's the center of this thing? Well, the center, looks like it's right here, actually. So this one's actually a little difficult because it's not, the center isn't right in the middle of, or isn't on a direct thing, but that's okay. So this center right here is obviously a -1.5. So the vertical shift is -1.5. You could also do -3/2. Both of those are true. Amplitude, well, if it goes from negative 1.5 all the way up to 1, the amplitude is in fact 2.5. You could also do 5 halves. Wavelength, well, wavelength is 2, which means b equals 2 pi divided by 2, which is just pi. So that's what you want to use. All right, what type of function is this? Well, starts at the bottom, goes to the top. This thing is a cosine. Not only is it a cosine, it's a negative cosine. So in a sense, our amplitude is actually negative. You don't actually have to write the negative. As we discussed, amplitude's a distance. It's kind of never negative, but if you want to use negative, that's fine. So I'm going to write negative. I'm going to use the fractions. 5 halves, right? This is cosine. On the inside, I'm going to use our b, and remember our b is pi, variable, and then our vertical shift. Our vertical shift is down 3 halves. If you wrote, so again, I use the fractions. If you wrote 2.5 for here, and you wrote negative 1.5 for here, totally good. So negative 2.5, negative 1.5, that works, okay? But yeah, that's it. So let's see if you can do those next 4 problems, okay? I want you to do those next 4 problems and see how that goes. And that is 10.5. So I'd like you to do 10.4, those 3, and then 10.5, those 4, okay? Hopefully it's relatively simple. If you run into any problems, I do have my computer on me, so please email me, okay? Thank you.